We're going to do a lesson from the Physical Science PACE 1115. And I know that when students get to the second checkup, which that is on page, I'm finding it here. I should have had this before I started the camera. Sorry about that. When they get to page P, there's often a lot of questions. And this is often a point where I sit down then with students to go back over some of the concepts that they maybe didn't really understand and try to clarify a few things. So I trust that this video will be helpful. I highly recommend that you watch this all the way through before you get to page P, and maybe even before you start working through the section on H-I-J-K in that section there. All right, let's begin by pointing out, and this is on page 10 of your PACE, this chart. There are several, I just have a few of them up here, prefixes, and it's very important that you memorize these. I'm warning you, you can fail your PACE test just by not having this list down pat. Some of these are obvious, like oct. You probably already know that oct means 8, and you might already know pent means 5, but some of these others may not be as familiar to you. All right, so make sure you study that, memorize that. Don't just keep looking back at it to use it, but really work hard at committing it to memory, and that will help you with your checkup, self-test, PACE test. All right? Then I want to clarify something here. That is that all of these bonds that we're talking about in this little section involve carbon and hydrogen. And that is a very common combination of elements that make up the human body and make up things in nature. And these can be hooked together. I have some drawn here. Carbons, 4 carbons here, and then a bunch of hydrogens around it. And I put together a model. Now you, I don't know how well you can see this. Here's 4 carbon atoms, and then we have oxygen atoms attached, carbon atoms in the middle, the black ones, hydrogens attached all the way around it. So we have 1, 2, 3, 4 carbons, and then 1, 2, 3 on the end, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. This is actually what this molecule right here would look like in 3 dimensions, okay? So we have 4 carbons, and then 4 plus 4, 8, and then 2 more for a total of 10. So this looks a little different than what you see in the diagrams in your PACE, because this is 3-dimensional and we tend to draw them in 2-dimensional. Now let's look at this. Because we have 4 carbons, we're going to use the prefix but, okay? And we're going to call this butane. All right, so this molecule right here is butane. If it's all single bonds between the carbons, then we use the ending ane, okay? If there is one, it only has to be one, double bond anywhere in the molecule, a double bond, then it becomes an ene. So I'm going to change this diagram over here, and I want to make this, instead of butane, I'm going to make this butene. So if I do that, let me erase this right here, I'm going to make this a double bond. Now when I do that, that gets rid of 2 of those hydrogens, because now the electrons of carbon are being shared between these 2 carbons, the electrons, and so there's not as many electrons available to share with some hydrogens. So in a molecule of butene, okay, it's still but because I have 4 carbons, it's an ene because we have a double bond. Notice what happened to the number of the hydrogens. Now the number of hydrogens is exactly double, all right, the number of carbons. When we had all single bonds, the number of hydrogens was 2 times the number of carbons. Remember, we had 4, 2 times 4 is 8, and then we add the 2 on the end. So the hydrogens is 2 times the number of carbon plus 2. But when we have an ene, we have to take away 2 of those carbons, and so now the number of hydrogens is exactly twice the number of carbons. Pretty simple, huh? Let me show you one more thing. If we stick in a triple bond between the carbons, that takes away 2 more hydrogens. So now we have 4 carbons, so it still is but, but now that we have a triple bond in there, the name changes. Now the name is ine. So that would be butane. Okay, you understand that? Isn't that cool? Just changing the number, the type of bond. Now, obviously, there can only be one double bond or only one triple bond. There can't be more than that in the molecule, at least at this level of chemistry that we're talking about. Notice what happens to the number of hydrogens. I have 4 carbons. Let's count the hydrogens. 1, 2, 3, 4, 5, 6. So the pattern here is we take the number of carbons, double it, and subtract 2. So the more bonds we have, the fewer the number of hydrogens. So we start with adding 2, then it's just double the number of carbons, and then we have to take away 2 hydrogens. This is something important that we need to know, all right, for the checkup and upcoming tests, as well as this. Now I want to show you a little secret here. I always point this out to students and it helps them remember this. You know your alphabet, so you know the order of the letters and the vowels in the alphabet. A comes before E, E comes before Y, A, E, Y. A, one bond, E comes second, double bond, the Y comes last, that's the only one, 3, triple bond, all right? Pretty easy. Now let me show you one more thing that's really important. I'm going to put this name up here. Let me change this back just for illustration's sake, all right? So this is butene, correct? Because we have the double bond in there. But if you have already done some of these pages leading up to the checkup, and then you get up to the score key and you see a number in front of it, you're like, I don't get it. Where did that number come from? And don't be tempted to just take the number from the score key and not understand why that number's there. Real easy, all right? Let me show it to you. Ready? If the double bond is in the second position, okay, here's the first, here's the second. If it's in the second position, then we call it 2-butene. Let's create one down here where we move it in a little bit further. Let's put it right here. And I'm going to do a triple bond and get rid of these 2 hydrogens. All right. So let's count how many total carbons we have. 1, 2, 3, 4, 5, 6, 7, 8. Since we have 8, we know it's oct. Because we have a triple bond, we know it's octyne. And then because it's in the 1, 2, 3, third position over, it's going to be 3-octyne. Did you follow that? Were you thinking that through with me and understanding where those numbers come from? Now, they're really, you don't need to necessarily know this, but I'll just throw this little in for free. We can only go out as far as the 4th, because then we would really be coming in from the other way, because these molecules are not always lined up from left to right. They can flip around. And so if this is the second position in, it's also the second position in from here. So we never, and for this molecule, we would never talk about first, second, third position. It's just first, second, and then coming in from this way, first, second. Don't worry about that. That's not a big deal. I'll just throw that in. So the number, again, is the position between the carbons. Now, one other thing that this section of the PACE talks about that I just want to clarify for you, and that is if there are ever double or triple bonds, then we do not have the maximum number of electrons. I mean, not of electrons, of hydrogens. If we do not have the maximum number of hydrogens possible, which means it's an ane, then we say it is unsaturated. Okay, that's all there is to it. If it's an ane, and so there's no double or triple bonds, and we have hydrogens all the way across top and bottom, and we have the hydrogens on the end, and it's maxed out, then we say it is saturated. Okay, that's all there is to it. Saturated, unsaturated, it's that simple, whether you have the maximum number of hydrogens possible. All right, so let's review again real quick. The prefix tells you how many carbons. The ending ane, ene, and ine tells you how many or what type of bonds are taking place between the carbons. We have to use this little formula for each of these to know how many hydrogens. All of this is important. It's all in the checkup. And then we put the prefix, the suffix together. We have the name of the molecule. And then the last thing is that the number comes from the position that that bond is located in the molecule. So I hope that helps you, and I trust that you'll be better prepared and more successful as you do your checkup coming up soon.